Somewhere along a creek bank in rural Ohio, a family out foraging for wild vegetables pulls up a cluster of white umbrella-shaped flowers growing at the water's edge. The leaves look like parsley. The root looks like a parsnip. It smells faintly sweet, almost like carrot. Nothing about it looks dangerous, and nothing about the setting looks dangerous either. A quiet creek bank on a pleasant afternoon, the kind of place people have foraged safely for generations. Within an hour of eating even a small piece of that root, one member of that family is having seizures on the way to the hospital, and the medical team receiving them has no specific antidote to reach for. This is not a hypothetical scenario constructed for a video. This exact sequence of events, with only the names and locations changing, has been documented in medical literature since at least 1670. And cases continue to appear in poison control records every single year across North America. The plant is water hemlock. Botanists classify it in the genus Cicuta, and multiple poison control centers, clinical toxicologists, and the USDA's own Poisonous Plant Research Laboratory describe it as the most acutely toxic plant native to North America. Not the most dangerous if handled carelessly over years of repeated exposure. Not dangerous only to livestock grazing in a pasture. The most acutely toxic plant on the entire continent for a single accidental ingestion. Capable of killing a healthy adult human within roughly an hour of consumption, with no chemical antidote available anywhere in modern emergency medicine to reverse its effects once they begin. Two things explain why this plant kills people every single year, despite being one of the most extensively studied poisonous plants in North American botany. With dedicated federal research laboratories devoted specifically to understanding it, one involves the specific chemistry of what water hemlock actually does to the human nervous system once ingested, which operates through a mechanism different from almost any other plant poisoning most people have heard of or been warned about. The other involves exactly why this plant is so icily and so tragically confused with several genuinely edible plants that grow in identical habitat, often within arm's reach of each other, along the same stretch of creek bank or marsh edge. By the end of this video, you will understand exactly what makes water hemlock so lethal at the cellular level. Why even experienced, careful foragers have died from misidentifying it despite real caution, and the specific, learnable physical differences that reliably separate this deadly plant from the wild carrot. Wild parsnip and water parsnip it is most often mistaken for in the field. The place to start is not with the poison, it is with where this plant grows, and why that location is exactly where the danger multiplies. Water hemlock is native across nearly the entire United States and much of Canada, documented in the USDA plant database in a range that stretches from Alaska to Florida, from Nova Scotia to California, with recognized populations in the vast majority of individual American states. It is not a rare, isolated species you would need to travel specifically to encounter, the way you might need to seek out a rare orchid or an endangered mountain wildflower. It grows commonly in wet meadows, along stream banks, in freshwater marshes, in roadside ditches that hold standing water after rain, and at the muddy margins of ponds and slow-moving rivers across the entire continent. This habitat preference is the first thing worth understanding clearly, because it is precisely the same habitat that several genuinely edible wild plants prefer for exactly the same reasons: reliable moisture, rich soil, and open sunlight at the water's edge. Wild celery, water parsnip, and certain edible members of the carrot family also grow in exactly these damp, marginal, streamside environments, often within a few feet of water hemlock itself. The plant that can kill you and the plants that are perfectly safe to eat are quite literally growing in the same mud, sometimes intermingled in the same patch of vegetation. Water hemlock belongs to the Apiaceae family, commonly called the carrot family or the parsley family in everyday language. This is the same family that includes carrots, parsnips, celery, dill, fennel, and parsley, the vegetables and culinary herbs sitting in most kitchens around the world. It is also, somewhat unfortunately for foragers, the same family that includes some of the deadliest plants known to temperate botany, including poison hemlock, a related but taxonomically distinct plant with its own separate toxic profile. This overlap between kitchen staples and lethal poisons within a single plant family is not a coincidence of classification or a strange quirk of nomenclature. The Apiaceae family produces an enormous number of species that share a very similar general appearance: compound, finely divided, fern-like leaves, hollow or semi-hollow stems, and small white flowers arranged in flat-topped or dome-shaped clusters called umbels, which look like tiny umbrellas or delicate lace doilies when viewed from any distance. This shared floral architecture is exactly why the family is sometimes informally called the umbellifers by botanists and gardeners alike. A trained plant scientist can often place an unfamiliar specimen into this broad family at a single glance, simply by recognizing the umbel flower structure, distinguishing exactly which specific species within that family they are looking at, especially in the field under casual conditions. Without a hand lens or a detailed botanical key open in front of them is a genuinely harder task requiring real attention to detail. And it is precisely the task that has cost people their lives when they got it wrong. Stay with me, because what water hemlock does inside the body once ingested is the part that explains why the outcome is so fast and so severe compared to many other plant poisonings people have heard of. The toxic compound responsible for water hemlock's lethality is called secutixin, a long-chain polyacetylene compound with the chemical formula C17H2202. Secutixin acts primarily on the central nervous system through a mechanism that researchers at the USDA's Poisonous Plant Research Laboratory and multiple academic toxicology groups have characterized in considerable detail over recent decades of published research. Secutixin functions as a non-competitive blocker of GABA receptors in the brain, a mechanism confirmed through laboratory studies using aqueous extracts of the plant's tubers. GABA, gamma-aminobutyric acid, is the primary inhibitory neurotransmitter in the mammalian central nervous system. It is the chemical signal that tells neurons to calm down, to stop firing, to maintain the electrical balance that keeps the brain from spiraling into uncontrolled runaway activity. When secutixin blocks the GABA receptor, it removes this inhibitory brake almost entirely, in a manner similar to the way certain other well-studied convulsant poisons like picrotoxin operate on the same receptor family. The result is uncontrolled, cascading neural excitation, which manifests clinically as severe, repeated seizures, often beginning within 15 minutes to 1 hour of ingestion and frequently proving resistant to standard first-line anticonvulsant treatment. Requiring escalating doses of medication to bring under control, this mechanism is meaningfully different from many other toxic plants people are more familiar with, which often cause gastrointestinal distress. First, nausea, vomiting, abdominal cramping, giving at least some warning window before more severe systemic effects develop and before a person or their companions realize something is seriously wrong. Water hemlock frequently skips that warning stage almost entirely. Documented clinical cases describe seizure onset as the first major symptom in a meaningful number of poisonings, arriving with almost no preceding signs to alert the victim or bystanders that anything is wrong, which is part of why the poisoning is so often fatal, even when medical help is sought as quickly as anyone reasonably could. As little as 2 grams of tuber per kilogram of body weight has been documented as a lethal dose in controlled livestock studies conducted by USDA researchers, and the tuber, the underground root portion of the plant, contains by far the highest concentration of secutixin of any part of the plant, which is exactly the part most likely to be dug up and mistaken for an edible root vegetable by someone foraging. Here is where the confusion with edible plants becomes the central danger, and where the specific identifying features become genuinely life-saving information. Water hemlock is most frequently confused with several plants that share its general apiaceae appearance and its preference for damp, streamside habitat. Wild carrot, also known as Queen Anne's lace, is one of the most common sources of confusion. Along with wild parsnip, water parsnip, and in some regions, wild celery. All of these plants produce white flowers arranged in flat or dome-shaped umbels. All of them have compound, finely divided leaves. All of them can grow to similar heights in similar locations. From a casual glance at a normal walking pace, they can look remarkably alike. The differences that separate them are real, learnable, and specific, and they matter enormously. The stem is one of the most useful and quickest identifying features to check first. Water hemlock stem is typically marked with purple or reddish magenta, streaking or mottled spotting, particularly toward the base near the soil line, and the stem itself is hollow or semi-hollow with distinct internal partitions running through it. If you slice the lower stem or the top of the root lengthwise, water hemlock characteristically shows a series of chambered, air-filled partitions inside, almost like a stack of small internal rooms, which is a distinctive structural feature that most of the plants it is confused with do not share in the same way. Wild carrot stem, by contrast, is typically covered in fine hairs and lacks the purple mottling entirely. Wild parsnip stem is smooth and grooved, but does not show the same chambered, compartmentalized internal structure when sliced open for inspection. The leaf vein pattern is the single most reliable identifying feature according to botanical references, including the USDA Forest Service's own plant identification guidance, and it is worth learning specifically because it works even when other features are ambiguous or the plant is at an awkward growth stage for easy comparison. On water hemlock, the veins running through each individual leaflet fork near the leaflet's edge and terminate specifically at the notch between the small teeth along the leaflet margin. Rather than running straight out to the pointed tip of each individual tooth, the way veins typically do on most of the confusingly similar edible species in the carrot family, this is a small, precise detail that requires close attention, ideally with a hand lens or, at minimum, very good eyesight combined with good natural light. But it is described repeatedly by botanists and extension specialists as one of the single most dependable features for distinguishing water hemlock from its edible lookalikes under real field conditions. When other more obvious cues might be ambiguous or missing on a particular specimen, the root and tuber structure provides another critical corroborating distinction that should be checked alongside the vein pattern rather than relied upon alone. Water hemlock frequently has a cluster of tuberous, somewhat parsnip-shaped roots gathered at the base of the stem, and this is precisely the plant part most often mistaken for an edible wild parsnip or wild carrot root by foragers, who dig the plant up specifically because the root looks appealing, familiar, and worth harvesting. The chambered, hollow internal structure visible when this root or the lower stem is sliced lengthwise with a knife is again one of the most useful confirming signs available that a specimen in hand is water hemlock rather than a safe edible alternative growing in the same patch of ground. Smell can serve as a supporting clue in some accounts, but should never be relied upon as a sole identifying feature under any circumstances. Water hemlock has been described in some documented poisoning cases as having a faintly sweet or parsnip-like odor, similar enough to genuinely edible relatives that smell alone has provided insufficient certainty and has actively misled foragers in documented historical cases, sometimes contributing directly to the decision to harvest and consume the plant. Here is the practical safety guidance that follows directly from everything above. If you are foraging in wet meadows, along streams, in marshes, or at pond margins, and you encounter any plant in the carrot family with white umbrella-shaped flower clusters, treat it as water hemlock until you have positively ruled it out using multiple confirming features, not just one. Check the stem for purple or reddish mottling. Check the stem and root for the internal chambered structure when carefully sliced. Check the leaflet veins under good light to see whether they terminate at the tooth notch rather than the tooth tip. If you are not confident in identifying every one of these features with certainty, the safest and only responsible action is to leave the plant alone entirely. Wild carrot, wild parsnip, and water parsnip are genuinely useful edible plants. But no meal is worth the risk when the alternative, if you are wrong, is a toxin with no antidote and a narrow window before seizures begin. If accidental ingestion of a suspected water hemlock plant does occur, this is an unambiguous medical emergency requiring immediate professional care, not a wait-and-see situation. Contact poison control or emergency services immediately and do not wait for symptoms to fully develop before seeking help. Since the onset of severe seizures can occur within 15 minutes to an hour of ingestion, leaving very little time to react once symptoms actually begin. Medical treatment typically involves activated charcoal administered to reduce further absorption of the toxin if given promptly enough after ingestion, along with aggressive anticonvulsant therapy, frequently requiring high and repeated doses of benzodiazepine medications to bring the seizure activity that cicutoxin produces under any kind of control. There is no chemical antidote that neutralizes cicutoxin directly at the receptor level, the way antidotes exist for some other poisonings. All available medical treatment is supportive in nature, aimed specifically at controlling the seizures. protecting the airway and supporting basic life functions. Until the toxin is gradually metabolized and cleared from the body over time, one piece of context worth knowing, and one that puts this plant's danger in useful, accurate perspective rather than pure, undifferentiated fear. Water hemlock is not dangerous simply to touch or to walk past on a hike. Extension horticulturists who have fielded homeowner concerns about the plant growing in yards and gardens have specifically noted that the plant poses no meaningful contact hazard the way poison ivy does. It is not harmful to touch with bare skin, and it does not need to be feared in casual proximity the way a venomous snake or spider genuinely would be. The danger is specifically and almost exclusively centered on ingestion. It also serves a genuine, documented ecological role in the landscapes where it grows. Water hemlock is a confirmed host plant for the black swallowtail butterfly and provides nectar for numerous pollinator species throughout its flowering period, meaning the plant is not an ecological villain that needs to be eradicated on site from every landscape it appears in. Only a plant that demands serious respect, careful distance from any food gathering activity, and correct multi-feature identification before anyone considers it in any context involving consumption. The confusion between water hemlock and its edible relatives is not a failure of intelligence or attentiveness on the part of the people who have been poisoned by it across the centuries. This has been documented. It is a genuine, well-documented case of two categories of plants, one deadly, one genuinely edible and nutritious, sharing enough visual similarity while growing in the exact same habitat that even trained botanists and experienced foragers exercise real deliberate caution before making a final identification in the field. The knowledge required to reliably tell them apart is specific, learnable, and exists in field guides, university extension publications, and USDA identification resources. Precisely because this particular confusion has cost documented lives repeatedly across centuries of recorded medical cases. From the earliest reports in 1670 through cases still being treated in emergency rooms today, the stem modeling, the chambered internal structure visible on slicing, the vein pattern terminating at the notch rather than running to the tip. These three features checked together and cross-confirmed rather than relied upon in isolation are the specific, learnable difference between a safe foraging trip along a familiar creek bank and a medical emergency with no chemical antidote waiting at the end of it. If you found this genuinely useful, watch the next video and do not forget to subscribe. See you in the next one.